Exponent rules 1, the quotient of powers rule and the product of powers rule. Quotient of powers. Remember that the word quotient is the answer for a division problem, and we're going to work with something that looks like this. So I will look at x to the third power divided by x to the second power. So we notice we've got powers because of the exponents, and because of this fraction bar we have a division problem. Product of powers, remembering that the idea of a product is the answer to a multiplication problem. So in these questions it might look something like this: x to the third power times x to the second power. Can you simplify this? Looking at the quotient of powers rule. So looking here, I want to expand this, and I want to think about the fact that I have 14, I have 2 x's, I have 3 y's on top, I have 3 x's and 2 y's in the denominator. Because we're dividing, we think about getting rid of, so I want to find out how can I get rid of some of what I see. So these 2 x's will cancel, these 2 x's will cancel, the 2 y's will cancel, and those will cancel. So because we've canceled those out, we're done with them. So what I have left is 14y in the numerator and x in the denominator. And that's it. Let's try it again. I'm going to expand this one to be 4a times a times a, 1, 2, 3, 4, 5, 6, 7 b's and 2 c's. And then I've got 2a, 1, 2, 3, 4, 5, and 3 c's. Again, I want to try to match up things that can cancel because we are working with a division idea. So those are gone. I can take out 5 of these. I can take out 2 of those. And now I'm looking for what's left over. So what I see here is 4a to the second power b to the second power over 2c. I'm not quite done though, because I do still have the 4 and the 2, which can be simplified. So my final answer here would be 2a squared b squared divided by c. Now I'm going to give you some time to practice this idea. Can you rewrite and simplify using the product of powers rule? Here I have x to the third times x to the fifth. So again I'm going to expand. So I've got 1, 2, 3 out of the first set, 1, 2, 3, 4, 5 out of the second set. So how many total do we have? We have a total of 8. So the answer to our question is x to the third times x to the fifth equals x to the eighth. Let's try one more time. Here I want to take what I've got again and I want to expand. So I've got w to the fourth, and then I've got w to the seventh. If I think about how many I've got in total, I have 11. So w to the fourth power times w to the seventh power equals w to the 11th power. Now I'm going to let you practice this. Now we're going to practice taking both rules and putting them together, because this is what you're going to have to be able to do ultimately. So we could expand. So I could do this. I could take my 3x's and my 2x's and my 5y's, and in the denominator I could take my 7x's and I could take my 2y's, and then I could use my idea of canceling. So that I could come up with y to the third power over x squared. But this is kind of a lot of work. So what if instead I used the idea of canceling without actually going through all this work? So the idea on top is I've got x to the third times x squared. Remember, this is like taking x to the 3 plus 2, which gives me x to the 5th. So now I have x to the 5th, y to the 5th, over x to the 7th, y squared. Now thinking about canceling or subtraction, so what I have here is I need to take these two, and I'm going to write those as x to the 5 minus 7, and then I'm going to take these two and write it as y to the 5 minus 2. So when I'm done, I have x to the negative 2 power and y to the third power. I know it looks a little different than my canceling one, but we'll talk about that later when we talk about negative exponents. Now I'm going to let you practice this. In conclusion, we worked with two rules today. We worked with the idea of the quotient rule, which ultimately says that we take the base and then we subtract our exponents. And then we worked with the product rule, which basically says we add those exponents. And then we practice some combination problems.